Welcome to a new lesson. In this lesson, we'll be solving a system of linear equations graphically. First, let's talk about what a solution to a system of equation is. A solution to a system of equation, in other words, graphically, is to find the intersection of two linear equations. For example, we have linear equation number 1, the blue line, and a linear equation number 2, which is the red line. When they intersect, the solution to this equation is a coordinate point. And therefore the solution is 2 units to the left with the x-axis, and 1, 2, 3 units up. So the solution to this equation graphically is -2 and 3. This means x is equal to -2, while y is equal to +3. Let's use this information to solve next couple examples. So we're going to solve a linear system by graphing. Solve this linear system. X plus y equals to 8. 3x minus 2y is equal to 14. I've already drawn the grid lines for you. What we need to do is graph it. Graph both of these equations. So the first thing we should do is we should label equations 1 and 2, the first equation and the second equation. There are a number of ways to graph these two equations. We could find the x and y intercepts and connect the x and y intercepts. We could also change these standard form of equations to a slope y-intercept form. And that's what I'm going to do. I'm going to change it into y is equal to mx plus b form. So let's take the first equation. X plus y is equal to 8. I'm going to subtract negative x from both sides of the equation, and we will get y is equal to -x plus 8. So that is our first equation we're going to graph. But before we graph it, let's do a similar transformation to the second equation. So here's my second equation. We're going to isolate the y. So I'm going to move the y to the right side of the equation, the 14 to the right side of the equation. So we're going to subtract 14 from both sides of the equation, and we're going to add 2y to both sides of the equation. In this case, the 14's cancel, the 2y's cancel, and on the right hand side we'll have 2y, and on the left hand side we'll have 3x minus 14. The next part is to get rid of the 2 by dividing both sides by 2. That means each and every term. So we'll have, if you continue, 3x over 2 minus 14 divided by 2 is 7 is equal to y. And that is our second equation we are going to graph. Now the reason why we changed these standard form into y-intercept slope form is simply because it's easy for us to graph, because we know what the slope is. For example, in the first equation, it is 1 over 1. The slope is -1, and the y-intercept is 8. So we start at +8 for the y-intercept, and for every unit down, because of that -1, we'll go 1 unit across. 1 down, 1 across, 1 down, 1 across, 1 down, 1 across. Using these points, we'll connect them and we'll draw the equation on the graph. And here it is. This line is y equal to -x plus 8. What about the next line? Our second equation. We know the slope is 3/2 right there. And we know that -7 indicates that it is the y-intercept. And so this is negative, oh, that's not -7. This is -7 right here. Right, -8 is right, 1 below it. And now the 3 means that for every unit, for 3 units up, 1, 2, 3, and we'll go 2 units across because of the denominator of 2. So 3 units up, 1, 2, 3, and 2 units across, 1, 2. So here are your points. So again, we'll continue 3 units up, 1, 2, 3, and 2 units across. Now we'll connect the points. And we'll get our second equation. Y is equal to 3 over 2x minus 7. So now the question is asking us, we're going to solve it. Now solving again means that we're finding the intersect point of these two lines. So the question is, what is this coordinate point where the two lines intersect? Well, this coordinate point occurs at 6 and 2. This means that x is equal to 2 and y is equal to, pardon me, x is equal to 6 and y is equal to 2. So this is our solution. After we complete our solution, we need to also verify it. Graphing, specifically if using an iPad like I'm using, or a ruler and grid paper like you're using, it's sometimes difficult to find a very accurate answer. So it's very important that you verify by plugging the value of x equal to 6 and y equals to 2 into both of these equations to see if you get the same answer. So let's do this right now. So our first equation and our second equation, so x plus y is equal to 8. We'll plug in the values of 6 for the x and value of 2 for the y. And will this equal 8? And yes, it does equal 8. What about our second equation? 3x minus 2y is equal to 14. If we plug in value of 6 for the x and value of 2 for the y, will this value give us 14? 3 times 6 is 18, and 18 minus 4 is 14. So it does work out. So we found a solution to our lines when they intersect, and we verify by plugging those values of x and y into the original equations. Now let's take a look at a different example. I'm going to solve a problem again using graphic techniques. One plane left Regina at noon to travel 140 or 1,400 miles to Ottawa at an average speed of 400 miles per hour. Another plane left Ottawa at the same time to travel to Regina at an average speed of 350 miles per hour. A linear system that models the situation is d equals 1,400 minus 400t, and d is equal to 350t. So the first equation is, we're going to consider our equation 1, and the second equation as equation 2. Now d is the distance in miles from Ottawa, and t is the time in hours since the plane took off. The first thing we'll do is we're going to graph the linear system, and then we're going to use the graph to solve this problem. And we're going to answer, when do the planes pass each other, and how far are they from Ottawa? Now on the right-hand side, I already set up the grid. The horizontal axis will be time, and the vertical axis will be distance. Now let's take a look at our first equation. D is equal to 1,400 minus 400t. And I'm just going to rearrange it so that the t's are right after the equal signs. So d is equal to negative 400 t plus 1,400. What's very important is that you see that the negative 400 is the slope. and the 1400 is the y-intercept. It looks like a slope y-intercept form equation. Based on this, we could plot this equation on our graph. So we'll start at 1400. So 1400 is right here on the vertical axis. And now take a look at the slope. It is 400 over 1. This means 400 miles will be traveled in 1 hour. And since it's negative, we're going to be traveling downwards when it comes to the slope, or backwards. So this means we'll travel 1400, so this is 400 down for every 1 hour traveled. Again, we'll travel 400 miles down for every hour. Again, 400 for every hour. And when we connect the points, we'll get a line like this. Okay. And the next part is we have to draw the second equation. Now the second equation seems to be a little bit more difficult, but really it isn't. The second equation is these equal to 350t. So what is the slope and what is the y-intercept? Well, there is no b value. You must be asking, well, what do you mean there's no b value? Well, there is a missing value, and it really is 0. What this means that the y-intercept, or b value, starts at 0. It starts right at the origin right here. And the slope, which is m, is 350. That means for every 350 miles, 1 hour is traveled. Or for every hour traveled, 350 miles are covered. So again, I'm going to focus on the graph. So we're going to move up 350, and 350 is approximately right here. This is 350. So that's traveled in 1 hour. So that's the second point, starting at the origin. Now again, we travel 350, and 350 plus 350 is 700, and 700 is approximately halfway between 600 and 800, and that's traveled in the other hour, so after 2 hours. So there you go, there's another point for you. And I'm just going to use a different color to make sure that we don't get those colors, those dots confused. And for the next hour, we'll travel another 350 kilometers, and 700 plus 350 is 1,050. And 1,050 is approximately here, and that's traveled in 1 hour. So here is the other point. So using those points, the green ones, we're going to connect them, and we'll get the second equation on the graph. So these two lines intersect at a specific coordinate. Now, what is this coordinate? Now, graphs not necessarily give you an exact value. Sometimes it's an approximation. In this case, looking at the graph, it's a little bit less than 2 hours. So now we know that it's a little bit at 2 hours. That's where the x is. And it's about at 600 kilometers. Pardon me, miles instead of kilometers. So It's again, it's a rough estimate. It's a little bit below 600 and a little bit less than 2 hours. So the planes pass each other 600 miles from Ottawa after 2 hours in flight. And let's take a look at our last example. Write a linear system to model the situation. To visit Head Smashed and Buffalo Jump Interpretive Center near Fort Macleod, Alberta, the admission fee is $5 for a student and $9 for an adult. In 1 hour, 32 people entered the center and a total of $180 in admission fees was collected. So the first thing we'll have to do is make a system of equations, usually 2 linear equations, to model this situation. Let's now reread the question, at least certain parts of the question. We know that there's admission fee for students and adults. We also know there are 32 people entering the center, but we do not know how many students or adults there are. But we also know that $180 was made in fees. So we could set it up that our x value, so we're going to let our x value represent number of students. We could say tickets or admissions. And we can let the y represent number of adults. Tickets. In this way, if we add x to y, we'll know that we sold 32 tickets, or 32 adults, or 32 people entered the center. Now, what about the cost? How do we incorporate that in? Well, if we know that one student ticket costs $5. If one student comes in, that's $5. If two students come in, that's $10. If 3 people come in for students, that's $3. But we do not know how many students came in, so we're going to call that 5x. Well, that's the same process for adults. We know 1 adult is $9, 2 adults is $18, 3 adults is $27, and so on. And 3y would be the cost of adults admission. When we add 3x plus 3y would be the cost of the entire admission, which is $180. So here are our 2 equations. Now, instead of changing these 2 equations into slope y-intercept form, we're going to use the x and y intercept for these equations. So x and y intercepts. Recall that the x and y intercepts have specific values. The x-intercept has a value of 0 for the y, and y-intercept has a 0 value for the x. So now what we're going to do is we're going to solve for the x-intercepts for both of these equations separately. So let's take a look at our first equation. And how do we do that? How we solve the x-intercepts. The first thing we should do, we should plug in 0 for the y. That becomes 0. And x then becomes 32. So our first x-intercept is 32 and 0. Now for the y-intercept, x is 0, so that this becomes 0. Therefore y becomes 32 in itself. We'll do the same process for the second equation. For the x-intercept, y becomes 0 for the second equation. Therefore, our answer is 5x is equal to 180. Then we divide both sides by 5 to isolate for x. And x is equivalent to 180 over 5, which is 36. now we're going to solve for the y-intercept. For the y-intercept, x becomes 0, and we're going to be solving for y. 9y is equal to 180 now. We divide again by 9, both sides, and y is equivalent to 180 over 9, which is 20. Now, since we have all x and y-intercepts for both these linear equations, we're going to use these x and y-intercepts to plot these two lines on a curve, on a graph, and then find the intersection point between these two lines. So our first equation, our second equation. First equation starts at 32 and 0, so it's right here, and finishes at 0 and 32. Here's our first equation. Now our second equation, and I'm just going to draw it in blue, starts at 36 and 0, so it's right here, and finishes at 20 and 0. And so here you go. Those are our two linear equations. And wherever they intersect is the solution. This solution seems to be at 27 and 5. What does this mean, 27 and 5? That means x is 27 and 5 is y. And recall that x is number of students and y is the number of adults. So we have 27 students and 5 adults visited the park. The last thing we need to do is we need to verify that these answers work, that the solution verifies with the equation. So we plug it into our equation. 27 plus 5 is 32. So that does check out. The first equation works. The second equation had 5x plus 9y is equal to the value of $180. Let's plug in those values to see if we get 180. 5 times x is 27 plus 9 times 5. Will that give us 100? And yes, it does. It does give us 180. So both of the equations are verified. That means 27 students and 5 adults entered the center. Now suppose if you decided to change the x and y variables, that y would be the number of students and x would be number of adults. Of course the graph would be different, but the solution would be identical. There will be still the same amount of students, 27, and still the same amount of adults coming to the center.